founder and president Munib Ahmed from Pakistan and vice president Matthias Augustine from Argentina. NSN is a community that shares a dictum of neurostatistics for all. This is more than just a motto, it's our mission. NSN is a global community of students, researchers, and professionals passionate about neuroscience, neurointervention, and data science. We are not just a research group, we are a movement breaking geographical and academic boundaries to push neuroscience forward and build a global network for like minded individuals. With members from all over the world, we foster collaboration through conferences, mentorship, and research projects. Our initiatives aim to make neuroscience more accessible and impactful. Today's session is a testament to this vision. This event is a collaborative initiative between the Global Alzheimer's Association Interactive Network GAAIN and NeuroStats Network, bringing together expertise in neuroinformatics and research methodology to advance Alzheimer's research. Through data sharing and innovative analysis, we aim to explore new ways to understand and combat neurodegenerative diseases. And today we have with us our host, Dr. Kali Xiao. She's a project administrator for GAIN, powered by Laboratory of Neuroimaging at the University of Southern California. With a PhD in genetics from the University of Cologne, she plays a key role in connecting Alzheimer's researchers worldwide to GAIN's federated data discovery platform, driving data sharing and innovation. That's all from my side, I suppose. Let's get started with promises to be a fascinating discussion.
Thank you. Thank you everyone for being here. If I could just have an idea of where everyone's calling from, if you could put your country in the chat if you want, just so I have an idea where everyone's from. So I am based in Los Angeles at the University of Southern California. At the Laboratory of Neuroimaging, we have a slew of neuroimaging resources, such as 2 advanced MRI scanners on site, a 3 Tesla and a 7 Tesla system. We have 21 petabytes of data storage for our own and our collaborator studies. And within this institute, we host the Global Alzheimer's Association Interactive Network. As the name suggests, GAIN is funded by the Alzheimer's Association based out of Chicago, Illinois. The Alzheimer's Association is a nonprofit organization that provides funding for Alzheimer's disease and dementia research, advocates for awareness and policy changes, and provides care and support for patients and caregivers. Before I get into GAIN, I just want to provide a bit of context for our goal and purpose. Basically, if you're part of an institute that has collected data on your local participants, such as demographics, genetics, neuroimaging, biomarkers, and medical history data, this would be a primary analysis. And if someone comes in and analyzes data without interacting with their participants or data collection, they are doing a secondary analysis. We'd like to encourage secondary analyses to get more use out of the data and derive new insights. And if you combine data from multiple studies and multiple sites, this would be a meta-analysis. The goal of GAIN is to encourage data sharing and the use of existing data to conduct secondary and meta-analyses. We have designed a federated data sharing platform to connect different studies from around the world to one platform so you can discover these studies for your research. At GAIN, we currently have 70 data partners from 18 different countries. These are the studies that have agreed to join GAIN and share data with researchers interested in their data. We have over 700,000 subjects represented, and there are over 38,000 data attributes. You can access all of this at gaindata.org. And the number above each logo is the number of subjects for that study. The 38,000 attributes span 8 different categories, such as demographic, medical history, behavioral, so this would be the participant's lifestyle and habits, neuroimaging from MRI and PET scans, cognitive diagnosis, genetics, mostly ApoE, but there are a few other genes as well, family history, and biosamples, such as cerebrospinal fluid and plasma biomarkers, and blood work measurements. You can preview data across all these attribute categories in the GAIN Interrogator, which is our flagship tool for data discovery and preliminary analysis. Here is a brief overview of the GAIN workflow before we get into an example. First, you decide on your research question. This can be inspired by your research interests or what is recently published in literature. Then inside the interrogator, you choose data partners that have your variables of interest in common. I recommend choosing between 2 to 4 since it can get overwhelming with more than 4 data partners. So we have this feature where you can pull multiple studies from different countries, different sites, and that would be not possible without GAIN. Then you would go through your variables of interest and map them to common pooled variables. Then you would define your cohorts of interest, which are subsets of subjects based on different attributes. Then you would set up your analysis. We have 4 analyses available directly in the web browser. You can do logistic regression, linear regression, Cox regression, and mental Hansel meta-analysis. Then you would agree to our terms of use. So the data that you can explore and gain is for preliminary purposes. You cannot publish the results directly from the platform. We do not provide the specific analysis methods that operate in the background, and you cannot adjust for covariates, for example. We also don't let you customize a graphical output since it is just to get an idea of the data, not for publishing. After you agree to our terms of use, you can see your preliminary results and interpret it to see if it's of interest to you. Finally, if you want to work on this analysis for publishing, you can apply for full data access from the individual data partners. Once you have their permission, they will send you their raw data and then you can do any kind of analysis with it. For the interrogator demo today, I have decided on evaluating the impacts of centiloids and ApoE4 on cognition in male and female participants. I will be choosing between 2 to 4 data partners using logistic regression with cognitive diagnosis as the dependent variable. The analysis will be divided into male and female participants, so it will be stratified by sex, and the independent variables are ApoE4 and centiloids. ApoE4 is one of the major genetic risk factors for Alzheimer's disease. There are 3 alleles on the ApoE gene, 2, 3, and 4. So E3 is the most common allele and it has no effect on Alzheimer's risk. E4 can increase the risk, and E2 is the least common and has been shown to decrease the risk for Alzheimer's disease. And a person's ApoE genotype can be any combination of the 3 alleles. And centiloids is a standardized scale for brain amyloid load measured by positron emission tomography or PET imaging. So typically a researcher would inject a radioactive tracer into the patient and this tracer would bind to brain amyloid, which can be visualized by PET imaging. The results are usually reported as SUVRs, which is standardized uptake value ratios. But SUVR results are tracer dependent, scanner dependent, and site dependent. So you cannot combine SUVR results from different studies. The centiloid scale has been developed as a standardized measurement. So definite amyloid negative young controls are anchored at 0 centiloids, such as this PET image on the left. And definite amyloid positive Alzheimer's patients are anchored at 100 centiloids in this image on the right. But the centiloid scale is not just limited to 0 and 100. You can have as low as negative 75 and as high as 275 centiloids. So once you have the centiloid values, you can compare and combine them across multiple studies, which really supports our spirit of data sharing and reuse. So now I will go into the interrogator at gaindata.org. Now this is the Gain Data landing page. You can see our 70 data partners. Some of them are offline because they're undergoing some updates and we are trying to reconnect with them. So the federated model means that we don't own or host any of their data. We just make a remote connection to their site and they can connect their data to the GAIN platform. You can hover over each data partner logo to see where they are located. You can also click on the logo to read the summary and go to their own webpage like this. And so there is some more information on the study and the principal investigator's contact if you have any direct questions. Our main analysis tool is the interrogator. Anyone can join for free to get started with previewing some data. After you've signed up and logged in, this is what you'll see inside the interrogator workspace. We have divided our studies into longitudinal and cross-sectional data sets. Cross-sectional data sets don't have an age attribute, and longitudinal data sets have age as an attribute, but not necessarily, they don't necessarily have multiple visits for each subject. So once inside the interrogator, you can explore the studies individually. For example, this study ideas is a study conducted in the US to explore benefits of conducting amyloid PET scanning for mild cognitive impairment and dementia patients. You can click through the attributes. So categorical attributes are labeled with AA, and numerical attributes are labeled with the number sign. For example, the centiloid value attribute contains the centiloid measurements I mentioned earlier. This is displayed as a histogram where with the centiloid values on the x-axis and the number of subjects on the y-axis. So you can see the centiloid values here range from below -50 to above 250. And there's a high narrow peak around 0 and a lower and wider peak closer to 100. So the first peak would represent the amyloid negative patients, and the second peak would represent the amyloid positive patients. And for our categorical attributes, you can view the subject counts by category. Back on the start page, you can also search for keywords across all data partners. For example, you can see who has collected ApoE genotype information by searching on the top right. As you can see for this study at NE DOD, you can see that they have separate attributes for ApoE allele 1 and allele 2, and then also a combined genotype attribute. Most other data partners would just have one combined ApoE genotype attribute. You can also search for who else has collected centiloid measurements. Now we have fewer studies that show up in the search results since it is a pretty niche attribute. For this demo, I will be pulling the Mayo Clinic Study of Aging, or MCSA, based out of Minnesota in the US, and the National Alzheimer's Coordinating Center, which is a US-wide longitudinal study. I would say one of the hardest steps is actually deciding on which data partners to pull, because all the data partners you pull need to have all your independent, dependent, and stratification attributes. So I have verified beforehand that both of these data partners do have centiloids, ApoE, sex, and cognitive diagnosis attributes. So it might take a few tries for you to land on the data partners you want to pull. So I'm just naming this. So once you've created your full data set and given it a name, you'll be taken to the analysis space here. Under data partners on the left, you can see the data partners you chose and then use the drop-down arrows to view all of their attributes. And your custom pooled variables will show up under my pooled data, which you'll see in a minute. So on the top, under the variables and cohorts tab is where you can view and set up your variables and cohorts. And then under the Analyze tab is where you can set up your analysis. For logistic regression, you would need a control and a case cohort to calculate odds ratios of the case outcome with your independent variable. For linear regression, you would need just one cohort, but two variables, an independent and a dependent variable to see if there's a linear correlation between the two. So Cox regression would only show up when you analyze longitudinal data sets. For this, you need one transition cohort and one independent variable to calculate the relative risk of converting from one condition to another. I can also briefly show you this later. And mental hands-on meta-analysis will only show up when you pool two or more studies. For this, you would need 4 cohorts, a control and a case cohort, and an unexposed and exposed cohort to calculate weighted odds ratios of the case outcome. So the odds ratios are going to be weighted with the number of subjects in the study. Now back to our example, we wanted to look at centiloids, so you can search for that across both data partners in the search bar here. Here is the centiloid variable for the Mayo Clinic study of aging, which you can see looks different from the other histogram from IDEAS, which had 2 peaks. The MCSA cohort are actually mostly cognitive normal participants, so that's why you only see 1 peak here around 0 centiloids. So click on map to a pooled variable, and then let's redefine this into a new binary variable. And so select map to 0 or 1. So you'll see now the histogram is flipped with the number of subjects on the x-axis and the values on the y-axis. You can use your sliders to determine your 0 and 1 cutoff, or you can type in a specific value. So for this, I'm going to say that 20 centiloids or below is 0 or amyloid negative, and 20 centiloids or above is amyloid positive, or 1. This value has been reported in literature to be a good cutoff for determining amyloid positivity, or you can enter your own values if you want to have a higher or lower tolerance for what you call amyloid positive. You can also use the second slider to exclude extreme values or outliers like this, but we don't need to do that in this case. So now click on create and name this variable. I'm naming this centiloid greater than 20 so that I remember what I said as my cutoff. So now you can see that it shows up under my pool data and it says 1 data partner, so we need to do the same for the other data partner. So now for NAC, instead of choosing a new pool variable, choose the one you previously defined. You can use the slider again or enter the same value as before, so 20. So 20 and below is 0, and then 20 and above is 1. We also mentioned ApoE, so we can search for that across the data partners. Interestingly, MCSA only reported whether or not someone has an ApoE E4 allele, so we can't get any more specific genotype information from this, but we can still work with this attribute. So let's choose a new binary variable, and then no is 0 and yes is 1. And then naming this ApoE E4. So NAC has provided specific genotype information. You can see each genotype has 2 alleles, which can be any combination of 2, 3, or 4. So you'd have 6 possible combinations. Let's choose the ApoE E4 variable from earlier, and we need to define this the same way as it was in the other study, which says that any allele is 4. For the E3 genotype, you can see it's the most common. It has the highest number of subjects. This is going to be 0. E3, E4 is 1. E3, E2 is 0. E4, E4 is 1. And E4, E2 is 1. And E2, E2 is 0. We should have 3 1s and 3 zeros. And click on Done. We just need two more variables. We need a cognitive diagnosis variable. This is a cognitive diagnosis variable for MCSA. As you can see, most of their participants are cognitive normal. This time, let's map to my values, which is redefining your own categorical variables. So for 0, you can put normal. 1 is MCI. 3 is dementia. We don't know what 4 is, so we can exclude that for now. And I will name this diagnosis. For NAC, the cognitive variable is called UDSD. And I'm choosing the diagnosis variable from earlier. You just need to make sure to type the same labels as before. So for 1, you type in normal. This will get grouped with the normal from the other study. If there's any kind of typo, this will create a new label. So we're going to exclude impaired not MCI, and then 3 is MCI, and 4 is dementia. Lastly, we need a sex variable. This is usually at the top of the list for each data partner, so this should be easy to find. So this attribute from MCSA is just called male. So let's choose new my values variable. So that means yes is male, and then no is female. And then this is from NAC. I'm choosing the same variable we just defined, and then just typing in male and female. So now we have our 4 pooled variables. And actually, as soon as you create one variable, you can see that an age variable is automatically created. This is the age histogram combined across both studies. And now we are ready to define some cohorts. We are going to create 4 cohorts based on diagnosis and sex. So go to the diagnosis variable and click on create cohort. For the cognitive normal cohort, change the cohort type to oldest recorded age. You can see we have 7 cohort types, and by choosing oldest recorded age, we are choosing participants that remain cognitive normal until the end of the study. If you choose the youngest recorded age, this is just a first visit, and somebody could have started out as cognitive normal and then maybe progress to MCI or dementia. So we want the cognitive normal cohort to be cognitive normal throughout the study. So check normal and then click on create cohort. This is going to be our cognitive normal and female cohort, so I will just type that in here. With this cohort still selected, go to the sex variable and choose female and click on add condition. We will also limit the age range to 50 to 90 to exclude the younger control participants and then the older participants who may skew healthier. So I'll just select range 2 and then type in 49.5 to 90.5 to include the integer values and click on add condition. Now close out of this cohort, and we can repeat this process for a cognitive normal male cohort. Remember again to change this to oldest recorded age for cognitive normal. Now let's create female and male dementia cohorts. You can also include MCI in your case cohorts by checking both MCI and dementia, but for now, let's just look at dementia. For MCI and dementia cohorts, you don't need to change the cohort type from youngest recorded age. So that means if someone has a dementia diagnosis on their first visit or the first time they are diagnosed with dementia in the study, they are included here. This is our female cohort. So I will choose female and limit the age range. And lastly, we will create a dementia male cohort. And now we are finally ready to set up our analysis. So go to the Analyze tab, and we are going to use logistic regression. Just click and drag your control and case cohorts. So make sure you are comparing female to female and male to male. And you can click and drag your independent variables. So let's start with ApoE4. Click on Add Analysis to set up the male analysis. And ApoE4. So when you have two or more analyses, you have to name each one. So the first one is going to be female, and the second one is male. And as soon as the analyses are named, the Run Analysis button becomes active, and now you're ready for the analysis. If it's your first time using the interrogator or the first time you've used it in a while, you see the terms of use pop up. You can always refer to it here above your results graph. Now we can interpret the results. We have odds ratios with 95% confidence intervals, and you can see the precise values in the chart at the bottom. So the odds ratio of ApoE4 associating with dementia is higher in females than it is in males, but both are pretty high. So an odds ratio of 2 would mean that someone with an ApoE4 allele is twice as likely as someone without an ApoE4 allele of having a dementia diagnosis. And both of these odds ratios are higher than 2. An odds ratio of 1 would mean that this independent variable has no effect on the outcome, and an odds ratio below 1 would mean that the independent variable is protective against the outcome. So let's keep this tab open and add more variables. You can actually add as many independent variables as you like. So keep an eye on the numbers here. These are the number of subjects that correspond to each condition. So for example, female, cognitive normal, and no ApoE4, and etc. So I'm just adding the centrally greater than 20 variable that we defined earlier. Because fewer subjects have centroid data, and when you add this variable to the analysis, the ApoE4 variable also automatically reduces the number of subjects to the ones who have both ApoE and centroid data. And we'll do the same for the male analysis and then run analysis. Now we have updated results. So we have odds ratios for ApoE4 and centroid greater than 20 for male and female participants. You can see the x-axis scale has increased to 40 to accommodate the high odds ratio and larger error bars here. So the odds ratios for ApoE4 are a little bit different now. So for females, it's 2.48, and for males, it's 1.98, which is different from what we saw earlier with 2.81 and 2.46. So again, it's because we're looking at outcomes from thousands of subjects here. And then now we're in the hundreds range because fewer subjects have both ApoE and centroid data. So we had said that centroid greater than 20 was amyloid positive, and this has a very strong association with dementia in female participants with an odds ratio of 17. And this is higher than the male odds ratio, which is still really high at 6. Again, these results are for preliminary analyses only, not for publishing, so you can't uh, download or publish this graph. If you want to work on analysis with these data partners for a publication, you can go back to the GAAIN data landing page and access the data request portals with the applied links below each partner logo. For example, if you are interested in that data, you can go to their apply link here. And this takes you to an external page where you can make your data request. Also, briefly, I can show you how to set up a transition cohort for Cox regression. So go to the diagnosis pooled variable, click on create cohort, and change the cohort type to age when a transition occurs. Let's say, for example, you're interested in the participants who progress from cognitive normal to dementia during the study. So for before converting, all subjects have this in common. Select normal, click on add condition, and then for after converting, select dementia. And I'll just name this normal to dementia. We will not worry about the age and sex attributes for now. So go to Cox regression, and then you can put your transition cohort here. And then let's use the centilloid greater than 20 variable. And click on Run Analysis. So on the right, you'll see the cognitive normal survival plot. It shows the fraction of participants remaining cognitive normal since the first visit at year 0 here. It doesn't mean survival or death, it just means cognitive normal fraction. And on the left, you'll see the relative risk value with 95% confidence intervals. And the relative risk here is 3.14. So the meaning and calculation of relative risk is different from the odds ratio we saw earlier. and I won't go into the details here. A few more things. You can save your pooled data set with the Save button on the left here. This saves your pooled variables and cohorts, but not how you set up the analysis. So if you don't save, you would lose all of this the next time you log in. So remember to save if you like how you set up your pooled variables. On the other hand, if you made a mistake or if you don't like how you set something up, you can just abandon the analysis, start over, and then this won't be here the next time you log in. If you like how you set up the analysis, in addition to the pooled variables and cohorts, you can use the Save button on the right here. You can access your saved pooled data sets and also saved analyses under these tabs here. You can also go to your My Account page to update your information and communications preferences if needed. And if you have published something from using GAAIN as our starting point, you can let us know about your manuscript details here. With that, I will go back to my slides. If you want to learn more about centilloids and how to transform your amyloid PET SUVR results to the standardized centilloid scale, you can go to gain.org/centilloid project, where we're hosting the calibration data sets you would need for conversions, so then you can share your amyloid PET results more widely with other researchers. You can meet me and my colleagues at 2 upcoming conferences this year, where we will be talking more about GAIN at ADPD in Vienna, Austria in April, and AAIC in Toronto, Canada in July. If you're attending as well, feel free to come say hi. We will have a GAIN exhibitor booth at both conferences. So thank you for joining me and NeuroStats Network today. Have a great rest of your day, evening, and weekend.